Okay, so from the problems that I had you guys take home and do, there are no questions on 1, 2, 3, or 4. Those were for you guys to do. Okay, so I'm not going to go back to those. Were there any questions on 5, 6, or 7 on the next page? On evaluating for a value for the function? Okay, so everybody understand how to plug those in pretty easily? Yeah. Okay. Do you notice that you could just type in the equation and look when x is one of these values, the y value is right next to it, but um, just make sure you showed your work here though. Okay. Those of you that are doing your work and you are getting this done and you're doing the work that you're supposed to be doing, keep it up. Okay. All I can tell for those people that aren't doing that, you have all this blank, you didn't do anything, is you are going to have trouble because you're not putting in the time and the effort for you to do some work on your own. And that's all I can tell you is that's where you're going to struggle. Okay, and why we are going to take the Unit 2 quiz on Thursday. That way I can try to get the unit to your teacher. Okay. All right, I believe we did 2 of these already before we left the class. So were there any questions on any of these problems right here? How to match the independent with the dependent? Um, what were the ones that we had already matched on those? Which ones did we match already before we left? I believe we did 2. Yeah? We matched 2 of these already, didn't we? Which one was? What were they?
Oh, okay, so the one that you did, like, it didn't match up, like, we did the wrong one.
Oh, okay, we did the wrong one. Okay. Which ones have we used so far?
We did the number of people in line added you,
Oh, okay, so the number of people in line.
and then the length of time you do it.
Okay, so number of people in line and the length of time. Okay, so the number of people in line ahead of you and the length of time and the length of time you will need to wait. Okay, so we've already done that one right there. There was the number of meals you prepared. I believe we used that one, didn't we? And what was the other part? The number of people you'll be. Okay, then it should be. Oh, okay, the number of people attending the potluck is the one that matched with the number of people you will serve.
No, the number of meals you do.
Oh, the number of meals you provide and the amount of people that attend the potluck. Which one depended on the other one?
The number of people you will be able to serve depends on the number of people for that.
Okay, so
I mean, the number of people.
number
The meals you prepare.
meals you prepare?
Yeah.
Number of meals you prepare is the independent part. Okay? And
Well, isn't it the dependent part? Because it depends on.
number of meals you prepared.
It depends on how many people attend the potluck.
Oh, okay, yes. You're right. Number of people that attend.
I don't know if that's right, 'cause isn't a potluck something where you only bring one meal for everyone?
That is correct. I believe a potluck is when you bring something, yeah? Yeah? The number of people that attend the potluck. Which one would match? Let's try to match the number of people that attend the potluck. Which one do you think matches that? The number of people matches the potluck? No?
The amount of money you'll be able to raise?
Okay, the amount of money you'll be able to raise. Okay.
2 below rooms.
It's right here? Yeah, okay. Now, some of them look like they could match with different ones. Yeah. But once you start getting some of those that do match, it kind of narrows it down though. Yeah. Okay. Now the main goal for that activity was you had to figure out which one depended on the other. Okay. The dependent part, once you figure out the dependent part, the independent part is pretty simple. Remember, all the independent parts are going to be your domain, and the dependent parts will be your range. Okay. So let me look at mine real quick so we can. So I can go ahead and X out those so we can clear that out. Alright, here we go. Does everybody have their handout? So let's see. We've already matched the length of time you will need to wait. That was the dependent part. And the independent part was the number of people in line ahead of you. So those two should have already been matched. We did those, I believe, in class. Now, what you said, I made a mistake on the one after that, where it was the amount of people you would feed. So let's make sure we get that one correct. So. Oh, the number of people you will be able to serve. So the number of people you will be able to serve, and the number of meals you prepare. I think that one was correct. When is it? Wasn't it? Those two match? Yeah.
But then we're told with the number of squares more cuts.
So say that one again. The number of
Squares more cuts.
It goes with the number of days in our student.
Okay, so number of squares Marshall cuts the pizza into.
I put the number of pictures of the topic. We'll take it out.
That's for the number of people attending the dance.
So let's take a look at that real quick. The number of pictures the photographer will take matches with which one?
The number of students attending the dance.
Okay, the number of students attending a dance. Okay, so let's match. So the number of students attending the dance is the independent part, and the number of pictures the photographer will take is the dependent part. Did everybody catch that? And we might end up doing a few corrections in a little bit. So let's see, the amount of strawberries you pick matches with. Okay, let's try that. So the number of jars you would be able to fill with jam, and the amount of strawberries you pick. Do you agree that the amount of strawberries you pick is the independent part? And the amount of jars you will be able to fill is the dependent part? Is everybody following with me on that? Okay. I'm just marking them off so that way whatever's left over should match. Yeah. Let's see, the number of orchestra members who go on tour. That one should be pretty clear. What do you think? Okay, the number of hotel rooms that you need to reserve. The number of hotel rooms you need to reserve will depend on the number of orchestra members who go on the tour. So the number of orchestra members is the independent part, and the number of hotel rooms they will need to reserve is the dependent part. Yeah. Okay. the number of cucumbers you have.
The number of pickles you can make.
Okay, so the number of cucumbers you have is independent to the number of pickles you can make. I never knew that pickles were actually cucumbers. I didn't know that until I knew it already before this, but it was within the last year that somebody told me that pickles are just cucumbers. And just before that, the difference between pickles and cucumbers, I think it's the vinegar or something that they just put the cucumber in some vinegar and it just soaks it all up. That's all. And the other thing I learned was that raisins are just grapes.
You didn't know that?
I didn't know that.
Are you kidding me?
I didn't know that raisins were just grapes. You know, just with sugar and dried up, I guess, or something. You know. So that was something that kind of caught me off guard. It wasn't until this last year that I found those two things out.
I didn't know the pickles thing, but I knew the raisins.
Yeah, that was something that I was like, why didn't anybody ever tell me that? Nobody ever said that in school. You know. So the number of cucumbers you have is the independent part. And the number of pickles you can make is the dependent part. Everybody agree right there with that one?
Mm-hmm.
Yeah? Okay. Let's see, the number of cookies they bake. That one should have been pretty simple to match, right? Number of cookies you bake, what would that match with?
I put it to the number of people attending the potluck.
The number of people attending potluck? Think about cookies. When people bake cookies, they're either trying to sell them.
The amount you will be able to raise.
That's what I'm thinking is that they're
That's
trying
what I
to
said.
sell them.
Yeah,
They're
that's
trying
what
to
I
sell
said.
them. Yeah?
Yeah.
Okay, so you guys feel that the number of cookies they bake is the independent, and the amount of money they will be able to raise depends on the number of cookies they bake? That's kind of been a typical sale that you made as you were growing up, yeah? So let's see if those match up. Little by little, they're narrowing down now, okay? The ones we haven't matched up, or I haven't got correct yet, is the number of people you will be able to serve was the number of meals you prepare. That was the very first one, wasn't it? Okay. So the number of people you will be able to serve and the number of meals you prepare. The number of meals you prepare is the independent, and the number of people you will serve was the dependent. So I want to make sure because I only got 2 left on the left side that haven't gotten matched. The number of people in line ahead of you should match with the length of time. So that one should have been already done. Okay. All right, so that leaves me with 1 on the left. The number of square Marshall's cuts the pizza into.
What was the number of visitors to your booth?
The number of visitors to your booth.
I thought that was the total amount of candy that you're handing out.
See, the total amount of candy you will hand out, and
Did you make them up?
So which ones are we left? I got the total amount of candy you will hand out. I got the number of songs performed.
That's like the duration of the concert.
Duration of the concert? Okay, so let me match that one. The number of songs performed is independent to the duration of the concert, yes? Alright, so I'm going to match that up. So now I'm narrowing everything down to, alright, the number of visitors to your booth. Maybe the number of visitors to your booth, do you think that one would match with the number of squares Marshall cuts the pizza into?
Sounds weird.
Does that sound right? The number of a pizza booth?
Is that pizza booth?
Yeah,
I've never been to a
pizza booths. Do you think
I've
those?
seen more candy booths than I've seen pizza booths.
Yes, I agree. I've seen more candy booths than I have seen pizza booths.
I don't know the total amount of candy you'll hand out and the number of people attending the potluck doesn't sound right.
Yeah, that one doesn't sound right. So the number of people on where's the potluck one? Because that's the one that hasn't matched up yet, right?
You don't know. It's under the number of people.
Oh, okay. So we said, so you think the number of people attending the potluck,
Would that one be the pizza one?
and the number of square pizza answer? Maybe those two could go together. Leave those two blank. See, the number of visitors to your booth, and we think the total amount of candy you will hand out. That's kind of, I think, like Garrett said, I've seen more candy booths than pizza booths, yeah? So let's match the total number of candy handed out. And the number of visitors to the booth. Which one is the dependent though?
The amount of candy.
The amount of candy handed out is the dependent because it depends on the number of visitors to your booth. I know, have any of you guys ever gone to, did any of you guys ever first meet Options for Youth at a booth? No? Okay, because we do that a lot. Like you know how the Hysteria Days
I've seen it.
is coming up? We have a booth and we always give out candy. So I think those two do kind of go together. Yeah. So now that leaves me with the number of people attending the potluck and the number of squares Marshall cuts the pizza into are the only two left that I have. Yeah. So the number of people attending the potluck, do you guys agree that's the independent? Yeah. And the number of squares Marshall cuts the pizza into would be the dependent. All right. Now this activity on figuring out the dependent and the independent, that was kind of, there was a couple little tricky parts right there. So let's go to the back side then. So now we're going to move over to this next part, okay? Now this one's pretty clear. You're basically going to dissect that sentence into what was the independent part and what was the dependent part. Now, just give me everybody's attention on this real quick. Because when you guys take this quiz on Thursday, you're going to have to just be able to identify on the equations. Now, you guys all understand the independent is always your x values, and the dependent is always your y values. Yeah? Okay. Which one is the domain? All your x's, and range is all your y's. Okay. You guys remember how to get the patterns on the tables to figure out the linear, exponential, quadratic, absolute value, that stuff? You are going to do several of those, okay, on the test where it's going to ask you to figure out what is it. Okay. All right. So let's see. John measures the length and the width of each side of the rectangle. So I want you to picture right now. You're measuring the length and the width of each side of a rectangle. He uses those values to calculate the area. So one of the things is calculating the area. The other thing is measuring the length and the width. So which one do you think depends on the other?
The area depends on the length and width.
Area depends on the length and the width. You guys, if the length and width are changing, the area is going to change, yeah? So the length and the width are the independent, yes? The dependent is the area. So then we would write right here. The values to, or you could just put calculate area. To calculate the area, you need to get the length and the width. Now, in that part, you're just kind of dissecting the fact that John, it could have been any other person. The dependent part is calculating the area. Yeah. So you didn't have to write word for word every part of that sentence, just the main parts that make up it. Okay. All right. Everybody okay right there? Yeah. Okay. Now this next one is kind of gonna look like the test question. Okay. It says y equals 4x plus 1. So y equals 4x plus 1. I want to show you something, okay? You guys remember all those input-output tables we kept doing and trying to figure out equations for? X values go there, right? Or I'm sorry, that's wrong. Does everybody see why that's wrong? Oh no, wait, I'm right. Yeah. Okay. This is f of, same as saying f of x, right? And over here is your 4x plus 1, which will give you your y, right? Or your, and you can plug in any numbers you want for x. You're not limited on which numbers you're going to pick, okay? But these numbers are independent of whatever you simplify. So for example, if I pick 1, for example, yeah? That means I get 4 times 1 plus 1, which when you reduce that, it'll give you how much? 5. So when I choose x for 1, f of 1 gives me 5. Which one of these is the dependent and which one is the independent?
Y is dependent and X is independent.
Good. Y is dependent and X is independent. Or in this case, X is the independent variable, right? Okay. Y is your dependent variable. Y depends on whatever 4x plus 1 gives you. X can be any number. Yeah? Y is dependent on whatever this is. Yeah? Does that make sense? And you see this equation can be anything?
Yeah. So is it okay if we put that equation in?
Y equals 4x plus 1 would be the dependent part. X is just the independent part because you can pick any, I can pick 0 now. Or I could have picked 100. And you see how I figure out what the y value will be for that? By just plugging it in. Here I would do 4 times 0 plus 1, which would give me a 1. 4 times 100, I'm just throwing in random numbers. Okay. And that would be 401. Yeah. So this number depends on whatever this value is, and y depends on all of that. Yeah. All right. Everybody okay on that one right there? Yeah. Okay. My domain, just to kind of make sure we're touching base on this part. Could I have picked any other numbers other than these? Yeah. So I'm assuming everybody realizes that this is a linear equation. Yeah. And a linear equation goes, you know, this has a y-intercept of +1. And what's the slope? 4/1. So I go to the y-axis at +1. I'm kind of just drawing a rough sketch, and I go up 4 to the right 1. It kind of roughly looks like this. Domain is all real numbers because I could have used a big negative number. It's just way to the left of it. It does have a y value that goes with it. All I got to do is plug it in here to get that. Domain would be all real numbers, and the range would be, what do you think? All real numbers, because it's forever going up and it's forever going down. There's no gaps in there. Yeah. That's something that you are going to have to remember. Part of that is the domain and range. You guys remember that from the last one? Yeah? Okay. All right. Now, next one. David measures how many inches his tomato plant grows every week. So when you read that, what are the main things that are happening? Tomato plant is growing is one of them, yeah? So what you can do is, tomato plant grows, that's one part that's important, yeah? What's the other part that was important? How many inches? It didn't say anything about the water he's putting or anything else. Those are the only two things being mentioned, right? All right, so which one depends on the other?
How many inches depends on
It's grown.
The tomato plant growing every week?
Yeah.
Okay. So how many inches? So you put how many inches depends on the tomato plant growing. At one point, I know we have a tomato plant and it's been growing and growing, but we just planted it a few months ago. But it seems like it's reached the point where that's probably as tall as the tomato plant is going to grow. And at that point, when the tomato plant grows, this dependent part will stop to increase. Yeah. So. Tomato plant grows. All right, Mark works full-time as a busboy. Does everybody know what a busboy is?
A dishwasher?
Not the dishwasher. He cleans up the tables after somebody's done. Typically the busboy is not like the server waiting on you at like TJ Fridays or Olive Garden or something like that,
But it's like it's
But if he's lucky, he can try to get the tip. But I don't know how that works because I used to work as the waiter, and I remember the busboy taking my tip. And I'm like, that was my tip, not yours. But he's cleaning the table, I wasn't, so I'm like, whatever. So I think sometimes I got the tip. I there before he cleaned the table. But sometimes
table, you're like running from
the
restaurant. You're like, no.
Yeah, we're trying to fight each other to see who gets there first, and it was kind of like whoever got it first was the one that took the tip. So I don't know how that works nowadays though, because that was a long time ago. So Mark works full-time as a busboy at a local cafe. He earns $6 per hour. Now, when you are a busboy or something like that, you do get minimum wage because your main money comes off of the tips, usually. So if you ever have anybody that works as that, they'll pretty much tell you that they make their money off their tips. Sometimes they can make, like at a restaurant, up to, and a good night, maybe more than $100 a tip, or for the night, which is pretty good. If it's cash, it's better because it doesn't get. Okay, so all right, so he earns $6 an hour, and he gets an additional $3 per hour for each hour over 40 hours a week. So just something that you want to know: if he works over 40 hours a week, that's considered overtime. So every hour he works after the 40, he still gets his $6 per hour plus $3 an hour after that. So really, he's making $9 an hour after he's worked 40 hours. So if he works 42 hours, those 2 extra hours after the 40 are paid at $9 an hour. So that's $18 in those 2 hours instead of $12 because he was getting 6 an hour. Does that make sense? Because later on, some of you guys are working already. I know DeAndre, I think you're working already. Anybody else working already?
I work with my dad once in a while.
Okay. Doing what?
Construction.
Construction? Okay. And Garrett, what are you doing?
I do part-time with my godmom. She does insurance inspections. And I go and close the orders for her.
Oh, okay. All right. All right. Eventually, you guys are going to be, I think you're closer, DeAndre, to your kind of like more of a consistent schedule. Yeah? Okay. If you guys end up getting jobs that are commission, just kind of be aware of those jobs. Typically pay the minimum, and you get a percentage of what you sell. So just kind of be aware of that, because I know when I was young, and this was me being like 11 and 12, going to do telemarketing, which was surprising to me now at this age. I'm like, I was calling people at 12 years old trying to sell them stuff. Nowadays, I don't think that would fly. All right, so he earns $6 per hour and then additional $3 per hour for each hour over 40 weeks. For every hour, 40 hours over the week. So what do you think would be the dependent?
How much work?
How many hours he works? Because how many hours he works will
No,
depend
So
on.
the amount of
no,
money
the amount of money
earns
made
depends
depends on
the
the hours he works.
No.
Because he can't make money if he's not working.
Can he work overtime?
Well, yeah. That's
Yeah,
also
but
additional hours.
that's
he's working.
hours. Like,
Okay, so
That's how much
the
you
money
get paid.
depends on the hours.
the money depends on the hours, you think?
No, I think the amount of hours that you work depends on how much money you make.
That's what I
No.
think.
How does that
No,
How does that
make
even work?
sense?
No,
Yes,
because
it-
look, the amount of hours he works can change with the amount, and so does the amount of money, but the amount of money he earns depends on the amount of hours
Yeah,
he
because
works.
he
The
can't.
Amount
Like,
of hours, the amount of hours he works depends on the amount of money he makes. That makes sense.
no, because how is he gonna make the money if he doesn't have the hours?
Well, we're assuming he didn't get fired and he's working, yeah?
Well, yeah, it says he's working.
Yeah, but he still needs like a certain amount of hours to make that money.
Now, the hours could change though.
Yeah, that's
That's
Yeah,
why I
still free
said,
money.
yeah.
No, the money shouldn't change because it's.
It does when it goes over 40.
When it goes over 40, it will
But it's more
change.
constant. So,
Okay, raise your hand. To me it made sense. The amount of money you make depends on the hours you.
Okay, why then?
wait, he just said
You
exactly
just
what
said
you guys
the
were
word.
saying.
No,
Is that,
He just
Oh,
said
it
the
is
amount
it?
of money.
the amount of money
depends
you
on how many
make
hours you work.
depends on
The
how
hours.
many hours you work. That's what you've been saying? Okay, so I was kind of confused. Alright, so we got that. The amount of money you make is the dependent, yeah?
yeah.
And the hours you work is the independent. Okay, so that was a confusing part of the independent. So independent is hours that you work. Alright, so we are all in agreement that the amount of hours you work is the independent and the amount of money you make. And you can just say how much money you make. So later on in life, like you say, you sometimes you work with your aunt and sometimes you work with your dad. So the amount of times that you work with them depends on how much money you're going to make. Yes? Does that make sense? Okay. All right. Just got to make sure we're all on the right ball. Sometimes I do make mistakes, so catch them. Okay. And I never have a problem with people. Hey, wait, I don't think that's right. That's the whole point of this. Yeah.
Did you get that whole thing recorded, that whole argument?
Yeah. Okay, that's all right. Okay, so are we okay on this one right there? Yeah? And remember, the videos are for you to go back and just go back and double check. Okay? All right. The number of gumballs, G, that can be packaged in a box with the volume V, cubic units, is given by that equation. So now that one's starting to sound more like of a math question. Okay. What things are we looking at here? Good. The main parts are the volume and the number of gumballs. Okay? Volume or gumballs, which one is dependent? The number of gumballs that are packaged in a box. Now, think about this. Gumballs
The amount of gumballs depends on the volume.
depends on the number, yeah, the size or the volume is the independent part. The dependent part is, you can only use one gumball. The volume of that one gumball is going to be way less than more. Yeah. So the gumballs is the dependent, and the volume is the independent. Okay. Now notice they said V represents volume. Okay. So that means G would be the dependent, because G represents gumballs. G would be dependent, and V is the independent. Yeah. You notice in that equation, G is equal to 40V plus 15. G doesn't represent X. G represents, G represents X and B represents Y in this case.
Isn't it
No,
T represents
G
Y and
represents
B
Y.
represents X?
Because
But G is the, oh no, G is the independent, yeah? Okay, so no, you're right.
No, G is
G is,
the
G is
dependent.
G is the, G is
G is
the,
Y.
G is Y. Yep. Right, good. All right, let's go to the last one. Jake works as a sales representative. He earns $12,000 per month. Okay, so this is a commission-based job. 8% on his total sales. $12,000 a month is not a lot. It's very, very difficult to live off of that a month, especially nowadays. Assuming his commission is way more than that. And typically that's what you guys are gonna start to realize if you guys start looking at commission jobs, that your base salary is usually gonna be pretty low because they want you to hustle and sell. That's where the commission will typically, if you hustle. But if you don't hustle and sell stuff, that's where you're gonna be like, well, you get what you earn, yeah? So just kind of watch out for commission jobs, okay? All right. You'll typically know a person's on commission when the minute you walk up, they're all in your face already and they're already trying to get you to buy something. You know that they're on commission. So their goal is to sell you. Get you out of that door with something you bought from them.
that might be
In a little while. Okay.
I might be getting into the Best Buy.
Best Buy? Okay. Sometimes, I've never felt like the Best Buy people are just like trying to push me. So I'm
You
not
go through
sure.
all the times, 'cause they're always-
It's not like when you walk onto a car dealership lot. It's
Yeah,
like,
car dealership is
you haven't
totally.
even looked at a car yet, and they're
And
already,
they're
like,
already-
asking for your driver's license. Oh, you want to look at this car?
Right,
You want to look at
right.
that
So
car?
that part, yeah, I can feel that.
You can hear them from like across the lot. They're like, I called
Man,
you.
I called you first. All right. So what is the dependent and what is the independent?
Earns 1,000 per month, it's dependent
Is dependent,
on him working.
so he earns 12,000. How about how much he earns instead? Because can't he earn more than 12,000?
Yeah. I put earns 12,000 plus 8% commission.
Okay, so, and that would be the dependent? All right, so he earns the minimum is 12, but he can make more than that with the 8% commission, yeah? All right. What's the independent part?
How much he spends?
How much he sells or his commission, yeah? So his commission is the independent part, and his dependent part is how much he makes, which is minimum of $12.75, right? He sells nothing, that's all he's gonna make for that month. Okay. All right. Okay, linear functions have a constant first, second, third, fourth, or what difference? First. Linear constants have a constant first difference. That means when you look at the table of values, the rate, the y over the x, that's where you find the first rate. So that's how you know if it's a linear or not. Okay. Cubic functions have a constant third. Quadratic functions have a constant second. Now remember, if the rate is addition and subtraction on those, that's why these are going to be. But what happens if the constant rate on the first, what if there's a constant rate on the first difference, but it's a multiplication?
It's
Exponential. So just put in your notes, be cautious. All of these, only if it's addition or subtraction. Yes? Because if any of those differences are multiplication, now remember, addition and subtraction and multiplication and division, remember the rules for these are the same and the rules for these are different than those? If you're adding something and if you're subtracting something, subtracting a number is the same as saying adding a negative number. For example, like this, 3 minus 2. That's the same as saying 3 plus a negative 2, okay? And then when you're multiplying something and dividing something, division is the same as multiplication. It's just multiplication of a fraction. So for example, 3 times x and x divided by 3. Yeah? X divided by 3 is still a multiplication of a fraction times x. Okay? So just kind of keep that in mind. These are the only 4 things that we're going to work with. Okay? All right. Quadratic functions are what degree functions? First degree, second degree, third, fourth. Quadratics. Ax squared plus bx. Second. Second degree, and you see that exponent right there of a 2? Linear functions, those are y equals mx plus b, and I want to remind you, this is your y-intercept, right? And this is your slope, your rise over your run. The x is to the first power, so that's first degree. Cubic functions, third degree. So it would be y equals x to the third plus something x squared plus something x plus something, or a constant. Yeah. All right, use finite differences to determine the degree of the polynomial that best describes the data. So in this data, first you got to figure out, is it linear? If it's linear, then it's a first degree function. If it's quadratic, what is the degree of the function? Quadratic functions are second degree. That means if the difference is in the second power, then it's quadratic. If it's in the third difference, then it's to the third power, as long as it's addition or subtraction. If the pattern involves a multiplication, that means it's an exponential, okay? Remember when we went over the pattern when it was positives, all the same number, and then it went to negatives, all the same number? That was absolute value, yeah? Okay. All right, which differences are constant? So from here to here, it's a plus 1, plus 1, plus 1, plus 1, plus 1. Everybody okay right there? Yeah. From -5 to 1 was how much? 6. And then is this another 6? No, how much is that? 11, okay. And then from here to here, 17. And then from here to here, 24. And then next one, 32. Okay, there is no constant there. And the rate, because these are all 1, I know the rates are not the same. If these numbers were different, that might be an indication it might be linear. So this is not a linear function. Is there any constant in the next differences then? From 6 to 11, what do you get? 5, okay. How about from 11 to 17? 6. 7, okay, there is a pattern there. What about there? 8? Okay, there is a pattern there, but it's not in the second difference, is it? It's in the third. That's a plus 1, plus 1, plus 1 cubic. That's a cubic function. Which differences are constant? The third differences are constant, and everybody see this is where the differences are right there. Identify the degree of the polynomial. It's a third degree. Any questions right there on that part right there? Because you are going to do that on the tests. I want to say 4 or 5 times maybe on the quiz. Yeah? Okay. Let me go ahead and everybody, we're going to do 8 and 9. And as soon as you're done, let's see if we can get them together. All right, the first part. As I'm going through that, does everybody agree if I just put +1? Do you guys agree that all those were a +1 difference? Yeah? Okay. I'll leave that one like that. How about from 32 to 22? -10, okay. 22 to 15, -7, okay. Next one, 0, okay. Next one, +9. And next one, 18. All right. Looks weird because 10, 7, 0, but then this is 9, 18. I do see some type of a curvature maybe. Yeah. But the only problem here is these are negatives though, and these are positives. So what's probably happening is it's a snake-like. So that would be probably it's going to be a 3rd degree. Okay. What goes here? +3, right? And then +7, +9, and +11? 9. All right, so now right there, that kind of throws me off because I'm like, wait, I get stuck right here. Right here, what do we get? 4, 2, 0. -2, and all right, so now I see a pattern of -2. So then this is a difference. Here's the first difference. Here's the second difference. Here's the third difference. Here's the fourth difference. So it's a 4th degree polynomial then. Which differences are constant on the 4th differences? And identify the degree would be a 4th degree polynomial. So it would be something x to the 4th power, x to the 3rd, then plus x squared, plus x, plus unknown. Yeah? Say it again. Are they ever going to be different? On the absolute value one, that one's going to be a little bit more. It's going to have because that one has negatives and positives also. All right. So number 8 is a 4th degree polynomial. Okay. All right. Number 9. Did you guys have trouble with number 9 at all? All right, so as I'm erasing you, you're finishing that, okay? All right, for number 9, 5 to 7, 7 to 9, 9 to 11, 11 to 13, 13 to 15. Is that one safe to say they're all +2? Yeah? Okay. I'm going to do that only here if I know they're all pretty simple like that. If it gets a little tricky, I would write it all out, though, okay? In order for you guys to do what I just did, do a favor then. Draw that arrow so that you don't get confused. You know, when you draw that arrow, it's because you're saying all of these are going that same number. Yeah? Okay. All right, how about on the next differences? What do we get? 14. What about the next one? 5? -1, -4, -4. Okay, nothing there. 14 to 5, that would be what? 9? Yeah. 5 to negative 1 would be a negative 6. Negative 1 to negative 4 would be a positive 3, yes? Oh, wait. No. You're right. Negative 3, yes? Right, at least they're all negatives. And then 0. Okay, nothing there. How about down 3? Plus 3, because we're going from negative 9 to down 10. We're getting more positive, yeah? So plus 3? Plus 3, okay, now I see plus 3, okay. So it's not in the first, it's not in the second, it's in the third. So that means it's a third degree polynomial. That would be x cubed plus x squared plus x plus some constant, yeah? So it's a third degree. All right. Use a graphing calculator to find a polynomial function for the data in exercise 7. Use a graphing calculator to find a polynomial function for the data in exercise 9. Let's skip those for right now because I want to go to the next part. Okay. We use the graphing calculator. For each table or graph, we will determine if it is a function or not. So everybody remember how to determine if it's a function or not? Vertical line test if it's the picture of the graph, right? How about the table?
Check for x's having multiple y's.
X's having multiple y's. So, and this is kind of weird. I'm going to pause because I want to. Okay, so you guys get that? Yeah? Okay. All right, so do we have n x's with multiple y's?
Yeah.
Oh, yeah. Right there, busted. So that means that is not a function. Okay, how about next one? Good?
Oh, that's 2 3s.
2 3s up. Busted. No. How about the next one? Yes,
Say one
function?
faithful one.
Faithful. All right, good job. All right, so far you see how the table you can do it pretty easily with that little trick? Okay. If it's just a graph, it's a vertical line test, so you just gotta pretty much scan it visually, and would that be a function? Yeah. Yes. How about this one right here?
No.
No. That one, if we were to see the table of values for that, we would get something like this. X's with multiple y's. Yeah, or 2 different y's. How about next picture? Yes. Next picture?
No.
Nope. Next picture? Nope. All right, those are pretty easy. That's pretty much a review from the first quiz, isn't it? Yeah? Okay. All right. All right, now the next picture. Just so you know, do you guys remember when you guys were doing triangles and you did sine, cosine, and tangent? That's what the graphs of sine, cosine are going to start to look like. We will do those, okay? What do you think? Function? Yeah. Next one, function?
Yes.
Yeah. What kind of parent function is that called? Absolute value. So that's when the pattern is going to have positives and then the same pattern but negatives. Yeah? Okay. All right. How about this one? Function? Yeah.
No, because it has 2 points. So
Now,
no.
look in your... As long as one of them's solid and the other one's open, that's okay. If they're both open, then it's even better. Now, if both of these were solid, then no, because then this x has 2 y's. Does that make sense? So that one would make it not a function. But because it's got a 1, I believe that dot looks shaded a little bit.
Yeah.
Yeah. So that dot is shaded. This one is clearly open dot. Yeah. So this one would be yes. Then. Had that other dot been solid, then that would have made it. Yeah. Okay. All right. Now these are called piece piecewise functions because it's pieces of graphs put together. All right. Solid dot, but then it's open. So right there we're good. Are we good all the way? This is a piecewise function, so that would be a yes. Okay. These piecewise functions are a little weird because especially when you do the domain and range of these, it's pieces of the x-axis and pieces of the y-axis. So the domain and range of these types of graphs get a little tricky because you got to write more detail. Okay. All right. So make sure when you guys are using the graphing calculator that you are aware of what information you're inputting. Right there, I needed to get out of it. Just look for one big graph, and there's my parabola. Very easy to distinguish. That is a quadratic equation. Okay. All right. Now you guys are going to be inputting stuff. Okay, go ahead.
My graph didn't come out like that.
Oh, okay. That's because of the zoom. It's zoom, and everybody type in 6 standard, and we'll all get the same looking graph. Yeah. Some of the calculators,
Mine's still the same.
but it's the same as that though. So did you hit zoom and scroll down to 6? Standard? Yeah?
Yeah.
Yeah. You have the equation right with us, very much. Okay, so if you don't, here's the thing, the calculator is only as good as the person that's using it. So if you're not getting typing it in the correct way, that's why you're going to have errors. So. All right. So sketch the graph of that for me real quick. And you see how you guys are going to evaluate when f is -2 and f is 0? Just go to the table of values. Everybody go to the table of values real quick. When f is -2, y is 0. And when f is 0, y is -4. So everybody real quick, you guys understand how to get those table of values for f of -2 and f of 0? Yeah. So your thing is you're not typing in information correctly. Okay. All right. All right. So everybody go to number 7 right there on that page. It says on one day the value of $1 US was equivalent to 70 cents as a euro. Okay. Now, have any of you guys traveled outside of the United States at all? No, remember? Okay. When you guys leave the country, for example, if you go to Mexico, a dollar, to use a dollar in Mexico is equivalent 16 pesos. So like $1.60. A dollar in Mexico is really $1.60. And then you got to think about it going backwards. If you come from Mexico to the U.S., you got to spend more pesos just to get $1. Does that make sense? It'd be more money because it's worth more over there. Now, if you took your dollar to Europe, because they use the euro, is your dollar worth more? It's worth less, because the dollar in the American dollar in Europe is only worth 77 cents of what it's worth here. Does that make sense? So that you kind of get an idea of how these numbers work. So when you go to Europe, you're going to spend more money than a dollar over here. Yeah? Europeans, when they come over here, their money is worth more when they come over here. And then if they were to go to Mexico, it's even worth more. So that's something that happens in life when you guys start to travel. You got to be aware of, does it benefit you? I mean, if you're going there, you're obviously going to have to pay the value of what their monetary system is. Okay. All right. So it says on the same day, U.S. was equivalent to 124 in Canada. So that means if you go to Canada, your American dollar is worth more in Canada than it is in Europe. Does that make sense? No. No, it just, like for example, when you go to Mexico or Canada, they pretty much will take the U.S. currency. Most people will, especially if you go to local mom and pop shops, they gladly pay them with the dollar because whatever the dollar is worth today in Mexico doesn't mean that's what it's worth tomorrow. Because the dollar could go up or down.
So it's like an investment thing.
It's kind of like an investment because you're actually taking a chance that they might make a little bit more money depending on who's setting the standard of what's going to go on. So it says write a function to represent the value of the Canadian dollar in euros. What is the value of the function for an input of 5 rounded to the nearest cent, and what does it represent? So we got to write an equation. Y equals mx plus b. So let's do one for the euro. Now remember our input is going to be for $1, yeah? So if we use $1 in Europe, that's only going to give us that much. Okay? That means this is my rate of change. My rate of change usually is represented by which one of these two? Or is the rate of change? M. So that means your equation would be y equals 0.77 times x plus 0. All right? And for the Canadian, what would be the Canadian one then? Would be y equals, what's the rate of change? 1.24 times x plus 0 because there's no other values. So go ahead and try to find out what is the value of the function when it's 5 rounded to the nearest cent for each one.
0.77 and the 1.24 would be the 47 cents, which makes that the difference between Canada and the euro. So what you would have to do is multiply that by 5 to find how much extra there is, more than the 5. And since that's how much extra there is, you just add it to the 5.
All right, good. So just remember, as sales start coming up pretty soon, when after Thanksgiving happens and you start getting all those sales, right? People are going to have a percentage off of a discount, right? It's the price tag times the percentage off. So whatever you get from that percentage when you multiply them together, that's what you're taking off because it's a discount, right? But in this case, it's not a discount.
230, whatever you have there.
Would be added to the $5 because that's $2.35 extra from the $5 you have. So let's pretend you're going from Canada to Europe and you have $5. Well, you really have $7.35 euro dollars
But you have,
because it's Canada dollars.
okay, you have $5 Canada,
Uh-huh.
and you're going to have.
And now you're going to Europe.
You wouldn't,
You wouldn't have
because
more.
you have less.
No, but the Canada dollar compared to the U.S. dollar is more.
Yeah.
No, the US dollar is more than Canada. Because a dollar in the US is $1.24 in Canada. But if
Oh, okay, I got you.
If you take $5 to Europe, you can get less.
Less, yes.
So you would subtract.
So you would subtract that.
So you'd only have 735.
So actually, you are correct. So it's the 235 because we're less. Canada has less value than the American dollar, right? So it would make sense that the
So it would have to go.
So no, you're.
Because if Canada's less
265.
going, well, because if Canada is
Canada's more than Europe.
no, Canada is worth less than
Canada is less than Europe because, and here's how we
because it's
relate
the
it.
difference between that and Europe.
So that's why we're gonna take away the 235, not add it.
Because a dollar in the US, they would give you more in Canada because it's worth more there, and a Canadian dollar is worth
Yeah.
less. So it would have to go up to get to the US because the US is worth more.
Not more than Europe.
And then the Europe is the same thing backwards.
$7.
So like in Europe, if you went there, their money is worth more than the US. So our money is worth less, so when we go there, we only get 77
Oh,
cents
yeah,
per
that,
dollar.
that's.
That makes sense? Okay.
Yeah.
So it would have to go from 124 for Canadian, that would have to be like, that's
So that's where our difference
more
is
than the
coming from.
Canadian dollar, so we have to go.
And that's why we're gonna take it away. That makes sense?
I thought that's what it was.
No, we added,
Well,
Because if you have
it's worth more in
five,
Europe.
$5.
it is,
Canada.
but
If it's
if you
worth
take
more than-
5, if 124 is worth 77.27 cents in Europe, if you take $5, it's gonna be less because Canada's, it's worth less.
right,
But you're going from Canada to Europe.
Exactly.
so that's
If you
why
take
we
$5,
you're gonna, no, we're gonna go
go
less.
down.
But if Canadian is worth less, why would we go down more?
Because it's worth less than $1. So if
Yeah,
we-
so we're going up so that to a place where it's worth more than $1.
No,
No, but
because if you
it's
only
already
took
worth less than
$1.24,
US.
you'd get 70.77 euros.
of
So you
that
wouldn't get
dollar.
more than 5 in Europe if you only took 5 Canadian dollars.
So here, I'll show. So when you go from US to Canada, you gain 24 cents. That's why it was 1.24. But when you go from US to Europe, you lose 23 cents. And that's because the euro is more, has more value than the US dollar. If you go from Canada to the US, though, you lose 24 cents per dollar. And then you gotta remember, the US dollar to the euro loses 23 cents on top of that. So if you go from Canada to Europe, you're losing 47 cents per dollar. So that's why when we multiply the 5 times the 24/7, we're gonna take that number away from 5. Yeah? So 5 times 0.47 gave us the 2.35. 2.35. So we have 5 Canadian dollars, but we're losing 47 cents per dollar. So we're really losing $2.35 total from our Canadian value, and we only have now whatever that difference is, 265. So now you only have 265 in euro. Does that make sense? 365?
Yeah, now it makes sense. Now it makes sense.
All right, so as long as we're not confused, and it's okay, it's a
No,
good thing.
no, no, it's two.
It's two, okay, that's all right. Always gotta make double check, that's why I never have a problem with people, wait, double check, I always want to double check, yeah. All right, so does this look a little bit clearer with that? Yeah, okay, that's good. All right, so now, it says, what is the value of the function for an input of 5? So we got that value. Now, do you understand why we set them equal to each other? Because they were both related to the US dollar. And there's a value of 0.47 that we got. When it's multiplied, we're losing money. So that value, when you input the 5, you got to take that number away from the 5 so that you can see what you actually have now in Europe. So now when you guys travel, as you guys get older, you guys are going to realize, okay, somewhere our money's going to be better. So it would be better to go to Europe or to Canada? Canada, your money's going to go further in Canada than in Europe. Yeah? But if I really want to go to Italy, so I know my US dollar is going to drop. Yeah?
I want to go to Canada.
Yeah.
My dad was born in Canada.
Canada.
More than half my family comes from Canada.
I've been to Canada once. It was nice, but I only was over there for a few hours.
My friend wants to take me up there to go snowboarding this winter,
Awesome.
but I have to get a passport.
They're a little bit, with your driver's license, you might be okay, but ever since I think 9/11, that kind of made it a little bit more difficult. All right, let's go to look at number 8 then. PC Haven sells computers at 15% discount. Discount means you're subtracting, okay? On the original price plus a $200 rebate. It says write a function to represent the final price of a computer at PC Haven. So we need to write y equals mx plus b. Is there anything that represents a rate of change? The 50%. Now don't write it as 15%, 0.15. You could write 0.15 if you want to. Is there an additional amount on top of that? $200 rebate? Would I put plus or would I put minus, do you think? Think about it. When you go to the store, you get a rebate. Are you paying more money?
They're giving you
They're giving you more. So,
less from the cost.
so it's taking away from the cost? Yeah? So we're taking away an additional $200 off your computer on top of the discount. That makes sense?
But I think I have a different calculation.
Okay, go ahead.
I got x minus x times 0.15 minus 200.
0.15, did you multiply it by x?
Yeah, and then
Okay.
you subtract the answer from that.
From the 200?
No, from x.
Oh, okay, because, yes.
The discount.
X is your, go ahead and say it again for me.
Y equals x minus parentheses. X times 0.15.
Okay, good. And then close that, minus 200, perfect. That's actually, when you do it like that, whatever you get from that is your final price. If you just use this, that's your discount off the original price. You still have to do this original price minus all of that. So this is actually the even more precise way to do it. Does that make sense? Because if you forget and you think, oh, well, whatever I get from here, that's what I have to pay. No, you got to remember, that's all your discounts that you're getting. You got to remember, that's why you're taking it all away from the original price. Okay? All right. What if the computer costs $2,500? How much are you going to pay? If you use this one right here, you guys see if you use that function right there,
That's gonna be 2,500. Oh, no,
that,
that's gonna be.
this number is just going to give you what your discount is.
So you-
And you still have to do the 2,500 minus all that. But if you use this one right here in the star, it's already input into it. Does that make sense? Yeah? Okay. Both of them are perfectly fine. One of them,
So
though,
then the X in the second represent would equal 2,500.
you put 2,500
Okay.
in for X for both of them. Yeah? So go ahead and put that in your calculator. I'll show you on mine over here. So we're going to put in, I'm going to use the star one, the one that Garrett gave us. Yeah? 2,500. Oops. Let me clear that. 2,500, and then I'm going to take that away from, I'm going to go ahead and put parentheses, 0.15 times 2,500. I'm going to close that parentheses, and then I'm going to take away the $200 rebate. And tell me if this is what you're getting, 1925? Yeah. So that's how much you're going to pay for it total. And actually I like plus tax. Yeah?
It didn't say
But it
that.
doesn't.
They didn't say that, but in real life you would understand. They'd still end up multiplying the tax. And I've actually went on my calculator to do the tax, and they always, the retail stores always round up the pennies to get that extra penny from you. Yeah. All right. Let me just make sure. You guys are okay on those? You guys are okay on those right there? How do I finish those right and figure out if they're linear, quadratic? Okay, that's that part. Just real quick, if you get a graph, so you got sine, cosine, tangent, secant, cosecant. These problems right here, you guys see that the domain is restricted here from the y-axis. So it'd be on x equals 0, domain is from 0 to positive infinity. And the range would be from negative infinity to, I believe, positive infinity, as long as there's no asymptote restricting right there. For the sine, cosine, and tangent, those are fine. Do me a favor, I want to do a graph of an equation real quick. Type this into your calculator, y equals 1 over x to the 5th power. Can you type that into the crafting calculator? And then we'll get going. Here's that. 1 over the parentheses, x, raise it to the 5th power. Oops. Delete that. Close it. All right, did everybody see that? I have it on the screen still. Now I'm going to zoom to fit it so I can look at it better. Alright, zoom standard then. Alright. Zoom in a little bit then. Okay, enter. Okay. Does everybody notice that we've got the graph, looks like it's coming from the left and then it's going to go down, 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 down right here? There's an asymptote right here. Yeah? And you see there's going to be an asymptote over here. If we look at the table of values, there's an error at 0. So from -1 to +1, there's nothing going on in between them. Okay? So just remember, you're going to be asked to be able to describe what's happening in there. Okay? All right. Make sure you finish the rest of that handout and have all the other stuff finished. On Thursday, we want to take the test quiz. Okay? You guys did awesome today. Thank you for all the good input, man.